Hello everyone, welcome back to Code for Teachers. I'm Michael Taggart, and this is Chapter 2, Section 3, the for loop. So in the last section, we went over the while loop, which is actually the base kind of loop. The for loop that we're about to explore is actually syntactical sugar for a special kind of while loop. But for loop is really useful in this particular case. So for loops repeat over a range, either over an iterable data type, which we haven't covered. Iterable data types are things you can loop through, and very soon we'll talk about those kinds of data types. So for loops iterate over those or over a range object, which we are going to see today. The big differences from a while loop is that the iterator variable is built in. If you remember when we did our countdown with the while loop, we had to manually define the count and then set it equal to 10 and then modify it inside of the while loop. And there was a way that we could make a mistake and accidentally end up in an infinite loop. For loops don't have this problem. Because of the way that we structure for loops, they're guaranteed to stop. So in most situations, if you know how many times you want to do a loop, or you have an iterable set that you want to loop over, you're going to be using a for loop rather than a while loop. It does, however, require the programmer to know how many times she wants to loop. Okay, so let's take a look at the syntax for a for loop. There are a few pieces here that I find students really struggle with, so we want to take our time and understand each piece. So this is a very simple for loop. For I in range 10, colon, indent, print I. Just take a moment and predict what the output of this loop might be. All right, now let's take a look at what the output actually is. What we get is every line an integer 0 through 9. So you'll notice we don't get up to 10. In computer science, and this is something to get used to, we start counting at 0. So what actually has happened is that we've created 10 integers in our range, and that's what the range function does, is it gives us back a list of integers that are the number you give it long, starting at 0. So if I ask range for 10 integers, it's going to give me 10 integers, but starting at 0. If I asked it for 11, it would give me 0 through 10. Okay, and then I have print I. So what's that print I all about? Well, let's break down the anatomy of this a little bit more. We have three important parts. We have the loop declaration, which is for, and that's kind of our keyword for a for loop, and we also use the word in as part of the loop declaration because we're going to say what is the thing we're going to be iterating over. Then that I, which notice is not specially colored, that's because we can use any variable name we want for our iterator. I is very conventional, but it's not necessary. You could call it whatever you want. And I is the iterator. That's the placeholder for the current value of the thing that we're looping over. And then the range generator in this case, which is range 10. So one way that I explain this to students often is that it's like counting on your fingers to keep track. If you're counting 0 through 9 or 1 through 10 or whatever, and you're pressing on your fingers to keep track of where you are, that's really what I is doing. So the first time through the loop, I is going to be equal to 0, and it prints that. The second time through the loop, so we go and do it again, it's going to be equal to 1, and then we print that. So I is whatever the current value is as we loop through this object. All right, let's take a look at an applied example, and this is a classic program, Fizzbuzz. Now, you may have experienced this math game, you may even have had your students play it. It's fairly popular, but it's not just popular in math classes in schools. It turns out that Fizzbuzz is a really popular technical interview question for developers. The reason being that if you can write Fizzbuzz in a programming language, it's a fairly good demonstration that you know what you're doing in the programming language. It requires enough understanding of a language that you can say that you're conversant. So here are the rules in case you're not familiar with Fizzbuzz. You start counting from 1 to an arbitrary number. Usually in classes, you all sit in a circle and just kind of count around until somebody messes up and then they're out, then we start again. If n, whatever that number is divisible by 3, you say fizz instead of the number. If n is divisible by 5, you say buzz instead of the number. And if n is divisible by 3 and 5, you say fizzbuzz. So as an example, if we were counting from 1, you'd go 1, 2, fizz, 4, buzz, fizz, 7, 8, fizz, buzz, 11, fizz, 13, 14, fizzbuzz. So that 15 is the first number that is divisible by both 3 and 5, which we're actually going to take advantage of in our code. Alright, so let's actually build a Fizzbuzz game using a for loop. Alright, here we are in our boilerplate code, and we don't have anything written yet, just some comments or title. The first thing we're going to do is decide how far to iterate. In later chapters, we're going to learn how to do this dynamically, so we don't have to set this as a hard-coded variable. But for right now, we're going to do that. So we're going to say, decide how far to iterate. We're going to say steps equals, and let's begin with it just being a basic 20. Okay? So then we're going to say, inside of our loop, or to make our loop, we're going to say for I in range. Now, if we said 20, it would give us, if you remember that syntax breakdown, the numbers 0 through 19, which isn't exactly what we want. And the good news is that we can give range more than one argument, and we can say start at 1, end at 21, because the second argument is non-inclusive. So if we want it to go up to 20, we say 21. But that's actually, again, not dynamic, because if we change steps, this won't update. So what we actually want to do is say for I in range steps plus 1. And this plus 1 is going to be something that you're going to be seeing pretty often in your code. We either have to do minus 1s or plus 1s a lot to take care of the fact that we start counting at 0 in a computer setting, but that humans don't. Okay, so for I in range 1 and then steps plus 1, so that'll give us the numbers 1, 2, whatever the steps we decided. What are we going to do? We're going to say either fizzbuzz, or just the number. So here's how we do that. If you think back to the way we wrote about it, we were saying if the number is equal to or divisible by 3, divisible by 5, divisible by 3 and 5. So let's write a conditional tree. And let's do it with the most exclusive first, just to catch those right out of the gate. So the most exclusive, the most rare occasion is going to be that the number is divisible by both 3 and 5, or, put another way, divisible by 15. So if you remember back to our even-odd checker, we can check for divisibility using the modulus. So we can say if I mod 15 is equal to 0, that's going to check to see if the number I, whatever that happens to be in the loop, is divisible by 15. We're going to print Fizzbuzz. Okay, continuing on with our conditional tree, elif I mod 5 is equal to 0, we'll print buzz. Elif I mod 3 is equal to 0, print fizz. Okay, so this is a good example of a conditional tree that needs more than one elif, because we have all told 4 possibilities, right? That the number is divisible by 15, it's divisible by 5, it's divisible by 3, or it's not divisible by any of those, in which case we just print out the number. So we've done those 3 special cases. Now for the base case, we're going to say else, and then just print I. Okay. So let's run our game here and see if it works out. Looks pretty good to me. Now, if you want one extra piece of this, and definitely this is a good interactive piece. You can easily modify this line 6 where we define our steps, and using the technique we learned earlier, we can get that input from the user. Input, how far should I go? And don't forget that that input is going to be a string, so we have to convert that to an integer. Good. Now when I run it, it'll first ask how far should I go, and if I say 50, it'll run Fizzbuzz up to 50. Okay, well that does it for our for loop overview. In our next 2 videos, we're going to begin our lesson plan using both for and while loops to do a new kind of exploration of multiplication and division. I'm Michael Taggart. Thanks for watching Code for Teachers.